Alright, hello everybody, and today we're going to be having a look at how I can graph some basic sine and cosine graphs right here. So before we get into that, we need to know how our original sine and cosine graph behave. So if I draw up two axes right here, our sine starts at 0, 0, and it's just some curvy thing that goes up and down like so. On the other hand, our cosine starts at 1 right here, and then it's just some up and down thing like so. So both of these graphs right here has a mean value at exactly 0, so they go up and down at around the point 0, and they also have an amplitude of exactly 1, so they only go up by 1 unit and down by 1 unit. Same with the cosine, it starts at 1, which is one of its highest points, and then it just goes down by 1. So the range of both of these graphs is between -1 and 1. And both of these graphs right here have periods of 2 pi. That means they repeat themselves every single 2 pi. So if we walk 2 pi along our x-axis right here, we're going to get to this point. Because notice after this point, the graph is just the same thing as it was before. So we have 2 pi right here, then after another 4 pi, it's going to repeat itself. Same with the cosine. After 2 pi, it's going to repeat itself. So it's going to return back to 1 right here, then it's also going to return back to 1 at 4 pi and so on. So let's have a look at our sine right here. What other features can we describe? Well, we know our maximum points and our minimum points, and they actually happen right between our x-intercepts. So we have an x-intercept at 0 here, obviously. We have 1 at pi because it's half of 2 pi. So that means we have a maximum point right here. It's going to be at pi over 2 because that's between 0 and pi, and for our minimum it's going to be between pi and 2 pi, which is 3 pi over 2. So our maximums and minimums will keep alternating up and down as we go. And for our cosine graph, it's going to behave a little bit differently because our maximum and minimum points are actually going to appear every multiple of pi. So we have a maximum at 2 pi right here, we're going to have a minimum at pi, then we're going to have a maximum at 0 pi, which is 0, then over here we're going to have a minimum at 3 pi, 4 pi, and so on. And our x-intercepts actually happen between our maximum and minimum points. So here we have an x-intercept between 0 and pi, which is pi over 2. We have an x-intercept here as well, which is 3 pi over 2, and then so on. So with all of that out of the way, we can finally move on to graphing some basic trig graphs. So we have here y being equal to 2 sine of x plus root 3. Well, what do we know just by looking at this equation right here? Well, this constant at the end right here, this is just the change in the y value. So our y translation, so that means our graph is going to go up by root 3. So that means our mean position will be root 3 because our graph will go up and down around root 3. And how about this 2 right here? Well, original sine of x has an amplitude of 1, but since we're dilating everything by a factor of 2 from the x-axis, that means now our amplitude is exactly 2. And just one more detail right here, whenever you have a negative in front of this 2 right here, the amplitude will still be 2 because this negative right here just represents a flip around the x-axis. So everything's going to be reflected in the x-axis. So if you have a negative, some constant in front of our functions right here, the amplitude is just that number itself. So now from this equation right here, we have a rough picture of what our graph should look like. So we're already given a domain to work in, and now we have to figure out our range somehow. It would be nice if we know our range. So our range, what exactly is that? Well, y will be between two bounds right here, and what are those bounds? Well, we'll have a mean position of root 3, and our graph oscillates up and down by a maximum of 2. So that means if we have root 3 over here, our mean position, our graph is going to go up by 2 and down by 2. And root 3 right here is like 1.7, so 2 is bigger than root 3. So that means our range is between root 3 minus 2 and root 3 plus 2. So it's just our mean position plus or minus our amplitude. So we're going to have root 3 minus 2 and root 3 plus 2. So we know that our sine graph, instead of starting at 0, 0, it's going to be translated up by root 3. So it's going to start here and oscillate up and down, something like that. So next from here, what can we figure out about this graph? Well, it would be nice if we can figure out where our x-intercepts are right here. So to find the x-intercepts, all we really need to do is let y equal to 0. So if we solve the equation 0 equal to 2 sine of x plus root 3, we need to solve for x inside of this domain right here. So that's just a basic trig equation that we can work out quite easily. So subtracting root 3 on both sides, and dividing both sides by 2. We want to find all the x's where sine of x is negative root 3 over 2. So it'd be nice if we can draw up our unit circle to visualize things a little bit. So remember what the sine represents, it's all the y value. So we're looking for all the points on our unit circle with a y value of negative root 3 over 2. So something like that. Negative root 3 over 2. And notice our domain is from 0 to 2 pi, so we're working from 0 all the way up to 2 pi. So looking at these 2 points right here. And how can we figure out these angles right here? Well, if you use your exact values table, you will know that the sine of pi over 3, that's exactly root 3 over 2. So the sine of pi and 3 is right here, and it has a y value of root 3 over 2. So that's when our theta is pi over 3. But we want this angle right here in the negative region. So you see, this height right here is root 3 over 2. This distance right here is also root 3 over 2. So we can argue that this angle that it makes with the positive real axis is pi over 3 as well. But the thing is, we want the angle from the positive x-axis that goes all the way around to this angle right here. So to do that, we can just think about going 2 pi and then subtracting off pi over 3. So that's going to give us a solution of x being equal to 5 pi over 3. So that's this solution right here, but we also need this solution right here. And just by some symmetry, you can kind of see that this angle right here is also pi over 3. So to get to this angle right here, we can rotate by pi, then just add another pi and 3. So our x is also equal to pi plus pi and 3, which is 4 pi over 3. So you see, from that we figure out where our x-intercepts are just by solving a simple trig equation. So we have one right here, which is 4 pi and 3, and then we have another one right here, which is 5 pi over 3. And just a small detail, if we look back on our domain right here, we're only going from 0 to 2 pi. And notice that 2 pi is exactly one period of our sine graph right here, so it's actually going to stop right over there. Because after that point, our graph is just going to repeat itself. And if you look on our equation right here, we're only shifting our original sine graph up by 3. So that means the points where our maximums and minimums occur right here, the x values won't change. But we know on our original sine graph in this domain right here that we have maximum at pi over 2 and we have a minimum at 3 pi over 2. So these points right here will still be pi and 2 and 3 pi over 2, but now we have to figure out their respective y coordinates right here. So how exactly can we do that? All we need to do is substitute these points into here and then solve the equation for y. So plugging pi over 2 into here, we're going to get sine of pi and 2, which is exactly 1. And then 1 times 2, that's exactly 2. And then plus root 3, that's 2 plus root 3. So we're going to get a maximum at the point pi and 2. And then our y coordinate will be 2 plus root 3. As for our minimum, we can do the exact same thing. We can plug this into our equation right here. So 3 pi and 2, plug it into the sine. We're going to get, well, we start over here and then we rotate all the way down to 3 pi and 2. So sine of that is just negative 1. So we're going to get negative 1 times 2, which is negative 2. Then plus root 3. So we're going to get the respective y coordinate being negative 2 plus root 3. Alright, so we've already come up with a whole heap of information about this graph. We've figured out the range, we've figured out all the x-intercepts, and we figured out where our maximums and minimums occur in this domain right here. So the final thing to do is to sketch a final graph for this thing. So let's draw up our xy axis right here. So we have our x, our y. Notice our x is between 0 and 2 pi, so we're only worried about the positive half of it. So it'd be nice if we can label where our 2 pi is, so maybe around here somewhere. That means our pi is halfway. Then we have pi and 2 right here, 3 pi and 2, and I think that's all we really need. And now time to put on some of this information right here. Well, first of all, let's put in our x-intercepts. So we know that we have them at 4 pi and 3 and 5 pi and 3. So 4 pi and 3 lies somewhere right here, and 5 pi and 3 lies somewhere over here. So those are our x-intercepts right there. And why not put in our mean value line, just so we know whereabouts our graph goes up and down around. So now our amplitude is 2. So from a mean value, we're going to go up by 2 and also down by 2. So let's put in our maximums and minimums. So we have a maximum at pi and 2, and then 2 plus root 3. So maybe it's going to appear somewhere up here. And then we're going to get a minimum at 3 pi and 2, and then negative 2 plus root 3. That's a pretty close value to 0, so maybe it's going to appear somewhere right here. So I've got most of our important points. Now we just need to put in our endpoints. Well, we know our sine will start at 0, 0, but it's being translated up by root 3, so it's going to start in our mean value line. And then our graph will end out 2 pi, but 2 pi is exactly the period of sine. So it's going to also end on our root 3. So we have all of these points here to work with, and now all we need to do is kind of connect the dots a little bit. Hopefully I drew things mostly to scale, so it turned out quite decent, but yeah, let's just try and connect the dots right here. So it's going to turn around to go back up to here, and down like here. So that's my rough sketch of this function right here. Maybe this point right here is a bit too high, so I'll just lower it a bit. But yeah, something like that, that's good enough. And the last thing to do is just to label these important points right here. So we have maximum at pi and 2, 2 plus root 3. Then our minimum right here at 3 pi and 2, negative 2 plus root 3. And also our x-intercepts are at 4 pi and 3, 0, as well as 5 pi and 3, 0, and then also our endpoints at 0 root 3 and 2 pi root 3. So that's quite a bit to have on one graph, but all of our important pieces of information is here. And maybe the last thing to do is just label this graph y equals 2 sine of x plus the square root of 3. So there you go. So yeah, that's pretty much it for this video. It's pretty much the exact same process for all the cosine graphs. But yeah, that's kind of my thought process when I sketch these sine and cosine graphs. So yeah, hope you guys enjoyed it, and I'll see everyone next time.